It all started in the 70s, the energy crisis. Energy was getting more and more expensive to use, and America had no choice but to make their buildings tighter, better insulated, and more energy efficient. In 1973, the Arab Petroleum Organization imposed an oil embargo on America, quadrupling prices of oil and some people not having any oil or gasoline at all. Now, this was in retaliation for the US deciding to resupply the Israeli military, and it was also to gain leverage over the post-war peace negotiations. Now, flash forward to today, where the snowball just kept rolling, and we have these buildings that are much more energy efficient, much tighter, and they need to be checked. Because if these buildings that are designed to be tight are actually loose in certain areas where there's air infiltration coming in, that's going to cause lots of issues that we'll talk about later. But it's also a problem if you build the buildings too tight. Now you don't get any fresh air. So who would have thought the Arab Organization for Petroleum would have helped us create the blower door? Okay, so how does the blower door actually work? All it is really is a big ass fan that you connect to the house and you suck all the air out of the house. That way you can find where the air is coming back in and you can calculate how much air is coming back in. Why is that important? You see, it's standard now in new construction to measure the success of a builder or contractor when they've built a building. We want to know, how tight is this building? Are you above the allowed limit and it's too leaky? Or are you too tight and now we need mechanical ventilation bringing in fresh air? So current code tells us that you can't have the building too leaky and you can't have the building too tight. This is one of the best ways to measure that, to understand exactly how much fresh air is coming in. So current code also says that you need a continuous air barrier around the entire envelope. That means that there cannot be any holes that are connecting the inside from the outside. The blower door is a great way to test a building to see if that air is coming in and where that air is coming in, checking for those areas of penetrations, trying to make sure that these buildings do actually have a continuous air barrier. So can't we just do that under natural conditions? I mean, do we really have to suck all the air out of the house? Can't we just look for holes? Well, yes, you can in certain situations, but there are situations where there are walls in the way and there's insulation in the way, and you can't really see exactly how tight, for example, a sliding glass door is, right? Or a recessed light. And so you need that pressure difference to pull the air and try to create a force. That way you can find it with things like thermal imaging, smoke pins. Under normal conditions, meaning just regular pressure differences that happen naturally between inside and outside, it's very difficult to find where this air is coming in, especially if it's not visually obvious what's going on. So the blower door is there to exaggerate that airflow so we can look for it. All in all, blower doors are to check for air infiltration, which is great if you're trying to comply with code, calculate to make sure if the building isn't too loose or too tight. It's also great to check for energy efficiency issues, but it's also used as a building forensic tool, and it's used as an indoor air quality tool. For example, if you have hot, humid air coming into a building and it smacks into a cool surface like, I don't know, a piece of sheathing that's not insulated or drywall, that's going to cause condensation. So now we're looking for structural issues. We're looking for mold growth. Same concept in the northern climates. If you're pulling in that cold air and it starts cooling surfaces, that warm ambient air inside the house is going to start smacking into cold surfaces, causing condensation. Also, what if that air is coming from a crawl space? What if that air is coming from an attic? These are nasty. These are going to lower air quality in the house. What if you're trying to track down a weird smell and you just can't figure out where it's coming from? Hey, blower door test, you could pull that stuff from the walls, right? So this is a great tool, not just for energy efficiency, but it's also a tool for investigation. And that's what we're going to get into in this course.